Hello. Hello and welcome to this video on Rust programming. In this video, we will talk about phantom data. We'll talk about mutability a bit, and we will talk about how we can move an object partially and how we can prevent that. So first up is phantom data. Now, this is an advanced topic, but it was there in the generic section of Rust by example, so I thought that I will pull it. Now, first we will go through that this example does not do what you call this example does not do justice with the concept of phantom data because the real uses is quite advanced for phantom data. So one of the main uses is writing unsafe Rust, and obviously that means you build low-level abstractions. You can implement iterators over raw memory using phantom data. You can design APIs with compile time guarantees, or you work with FFI or custom allocators. Now, these are somewhat advanced topic which we will cover later, but the description is for the sake of completeness. Now, if you look at the documentation, it says zero size type used to mark things that act like they own a key. Adding a phantom data T field to your type tells the compiler that your type acts as though it stores a value of type T, even though it doesn't really. That means its size is 0, okay? And it is checked statically at compile time only. At runtime, there is nothing you do with phantom data. Phantom data doesn't do anything at runtime. So suppose we have a tuple here or a tuple, however you pronounce it. So we have two parameters in the mix. So we have one parameter A and the other parameter is phantom data of type B. Then we have phantom struct, which we have first as A and phantom as phantom data B. Now see both derive from partial equality to allow for equality. Now we create two objects each from both the tuple and the struct. So the tuple is of type char f32 and char f64. The f64 goes to phantom data. Okay, and the character is q. So then we construct two structs as well. So we have char f32 and char f64. Now, if you want to say, for example, compare the two tuples, then there'll be type mismatch because this phantom data will not match of tuples. Similarly, for structures, you can't do a match here. You can't use equality. Okay? Because if you see, then it will tell you that this char F32 does not match with char F64. So that's a simple trivial example from Rust by example. But if you want to see real uses, then we will have to advance a bit further. And while writing on safe Rust and tutorials on safe Rust, we will see the example of first three. How we can have iterators over raw memory, how we can build low-level abstractions, and how phantom data is used in Rust. So at this moment, we are not going to discuss any of these three, but rest assured that in future we will discuss the top three. And API's design would come pretty late, okay? So is FFI. These two examples will come very late because we need to cover a lot of ground before we can deal with these. After finishing the standard Rust, I will cover the what you call functional programming, followed by multi-threading, followed by native programming. And I'm not going to cover these three as well very soon. The priority of functional programming, multi-threaded, and network programming is higher than these. Ideally, you shouldn't be writing on safe Rust, but once we do network programming, we will finish network programming, then we will go into unsafe Rust and all those. So we have quite a bit of ground to cover before we can discuss all this. The second example is of mutability. again from Rust by example. So suppose we have an immutable box of 32-bit unsigned integer and we borrow it. Okay. So when we borrow, we can change the mutability. Okay. The ownership and mutability both change. So now the data inside this 5u32 is owned by mutable box. It is no longer owned by mutable box. So at the time of movement, we can mark it mutable and then it will become mutable. And we can modify the contents of the box of the data contained inside the box. So that is mutable box content. If you want to see it running, I can show you. So this would be in mutable, right? And we can say cargo run, and there you go. The third example is of partial move. Suppose we have a struct person which has two fields, name and age. Name is of type string and age is a box of unsigned 8 by 8-bit integer. Okay, unsigned integer. Now, if you implement drop trait for person, you can't partially move this. The drop trait will prevent you from partially moving it. Now we create an object of the struct person. We have a name, Alice, and age is 20. Now we can deconstruct this object person and we take the name and we reference the age. Okay. So you will have age and name here. Now, if you try to take a borrow of this, it won't work. Okay, because partial move will happen here. Right? Now the person cannot be used, but person age can be used here because age was referenced. Name was moved, but age was referenced. So if you want to take only borrows, then we can do a reference, then this will work. Okay. But if you don't borrow it, a partial move happens and it won't work. So to show the full program, I will just refer it, and this would be an partial move. So the example talks about partial move and how it works. So these were the three examples I wanted to talk about, and in the next video, we will discuss lifetime and how we can assign custom lifetime to different objects and how Rust uses lifetimes to ensure the guarantees which it gives. So I hope that you have enjoyed this video. There was not much to it because we didn't go into details of phantom data. So it will be a while before we use phantom data in our code. So I would request, if you want to know more details of phantom data, let me know in comments and I will discuss it earlier, probably by writing some on safe Rust, and I will show you how we can iterate over raw memory as well. So let me know in comments if you want details of phantom data. The mutability example is very simple, but it was an important concept, so it was covered, and partial move was also an important concept which we have covered. So in the next video, we will discuss the lifetime, and let me know in the comments what would you like me to do, how you want to progress. So my next priority is covering the lifetimes, followed by macros, and then standard library. And then we'll go to the functional side, followed by multi-threading, followed by network programming. So with this, I'll end this video here and I'll see you in the next video. So till then, stay curious and keep programming. Enjoy.